Hey guys, this is Fadex, and today we're gonna be starting a series. And this series is gonna be about creating a kind of a 2D Minecraft slash Terraria clone. So yeah, let's get right into it. In the first episode, we're gonna be looking at chunk generation. So first off, I'm gonna set the default clear color to some kind of blue, so it would resemble the sky. Okay, something like this. And now we're gonna create a world node, world environment. I'm gonna call it world. And now we're gonna create a new scene. Well, let's first save this into scenes and world.tscn. Now the new scene is gonna be a node 2D, and it's gonna be the chunk scene. Okay, let's save it into. I'm gonna put it into a new folder called instances. And just gonna put it here. And then we need one more scene called, well, this is gonna be a static body 2D, and it's gonna be the block scene that's gonna hold all our blocks. So I'm gonna save it into instances block. Okay, so first off, let's create the block scene. I'm gonna set the grid. I'm gonna say show grid and configure snap. So because all our sprites are 32 by 32 and the grid is gonna be 32 by 32, I need to be on that grid. I'm gonna set this to like 16 by 16, so I would have more, I could edit it more perfectly, more precisely. So now let's add a new node, and it's gonna be the sprite node. And I created some sprites here, so I'm gonna use them. Let's put stone in there as a placeholder, okay? And the third thing that the block is gonna have is the collision shape, obviously. So let's set it to rectangle. Let's then drag it out, so stretch it out so it would fit the block. And that's the nodes for the block. I'm gonna then attach a script to it and create a basic behavior. So let's set the path to scripts and block.gd. Okay, and here. So the block is gonna have a few variables. The first one is the block type, I guess, which is gonna be set from the chunk parent. We're gonna do that later. And then we need to get all the sprites from the sprite folder. So I'm gonna say var block sprites, and I'm gonna make an array, and the array is gonna contain all the preloaded sprites. So I'm gonna say preload and put the, I don't know, grass first, for example. Okay, now the order of these sprites is really important. So I'm gonna say grass first, then I'm gonna say dirt, then I'm gonna put stone in there, and finally the bedrock sprite. Okay, and then what I'm gonna do in the ready function is set the sprite to according to the block type. So I'm gonna say get node the sprite dot texture equals to block sprite block type. And what this is gonna do is set the texture of the sprite to the block according to the block type. So if the block type is 0, it's gonna set the texture to grass. If the block type is 1, it's gonna set it to dirt. Okay, now this is the basic block behavior done, and we're gonna leave the block node for today. Now let's get right into the generation. So I'm gonna attach a script to the chunk node. Let's put it into scripts and call it chunk.gd. Okay, now first off, we need a few variables. So even before I started this tutorial, I added a script. It's called soft noise, and this script contains a few soft noise algorithm, like from a few dimensions. So I'm gonna use one from there. So let's preload it. I'm gonna say var noise equals preload, and then the soft noise script. Then we need the then we need the block scene, like the block prefab, you would call it. So I'm gonna preload the block scene. Let's see, instances, block, so I could instantiate it. Then what I'm gonna do here is create an enum called block types, which is gonna hold all the block types. Now, remember how I told you that the order of these is really important? So what I will do here is say grass, dirt, stone, bedrock. And what enum does is it assigns a number to each of these words, each of these keywords. So grass is going to be 0, dirt is going to be 1, stone is going to be replaced by 2, and bedrock is going to be replaced by 3. So that is the same order as these. So it's going to be easier for us. So next up, I'm going to create a few more variables. First one is going to be the world depth, which is going to hold the amount of blocks that resembles the world depth, basically. So I'm going to say it's going to be 64 blocks deep. Another one is surface height, which is going to say how high the surface can be. I'm going to say 64 too. And then I'm going to set the chunk width, which is going to hold the amount of blocks that the chunk, basically the size of the chunk. Okay, so now we can get into the generating. So first off, we're gonna create an instance of the noise script, or basically a soft noise instance. So I'm gonna say var soft noise equals to noise.softNoise.new, which is gonna create a new instance of the soft noise. Now here we can set a few parameters, one of which is the world seed. So we can just put some number in here for now, and then we can randomize it. So now I'm gonna create a for loop, which is gonna iterate over the x coordinate. So I'm gonna say for x in range from 0 to chunk width. Okay, and then I'm gonna calculate a y for each x. So I'm gonna say var y. Now I want the number to be whole, so I'm gonna floor it, because the y is gonna be like a offset of a block. So 0 is gonna be on the 0 coordinate, 1 is gonna be on the like -1 grid coordinate. You will see. So, and what I'm gonna generate the noise here. So I'm gonna say soft noise dot open simplex 2D. Open simplex is a noise algorithm similar to the Perlin noise, but you know, open source. And now for the parameters, we have in open simplex 2D, as you can see, we have 2 dimensions. So we are only going to use 1 dimension, because we're generating the noise only according to the x variable. And what I'm gonna put here is get global transform. Now what this does is it gets the global position in the world. And this is going to be important, because you will see, I will explain it when we come to it. I'm going to say get global transform dot origin dot x. This is going to get the x coordinate in the world. I'm going to divide it by 2. Now, by 32. Now, I'm dividing it because we're working in 32 grid size, but in the loops we're working in like block units basically. So 1 block is 32 width, has, you know, a width of 32. So I need to divide this by 32, so I would get the transform for the block, not for the like grid coordinate. Now I'm gonna say plus x, and this is what makes the difference in the chunk. So I'm basically saying get the global origin, and from there for every x generate a y for every x in this for loop. Okay, now I'm gonna even multiply this number by some really small number, so basically divide it. And this is really important, because what soft noise does is it makes, you know, like a fluent round noise, I would say. So it doesn't give like really random numbers. But so we say, give me the noise for x, and it gives you like 1. Give for x0, and it gives you 1. Give me the noise for x1, and it gives you a number that is quite random from the previous one. So I need to get a noise for a closer number. So I will say, give me for a noise for 0, and it gives you 1. Give me a noise for 0.1, and it gives you a close number to 1. Okay, so that's why I'm multiplying here by a small number. And now the y parameter is gonna be 0 because I'm not using that. Now this noise generates a number between 0 and 1, but I want a number between like 0 and the surface height that I have here. So I'm gonna say times surface height. Okay, now in my experience the surface height is too much, so I'm gonna even more divide it by some fraction, so it would give me like a normal height. Okay, so now we have generated y for the x. So now we can try creating the block. So I'm gonna create a new function for that, func new block, which is gonna have 2 parameters. First of which is the block position, and the second one is the block type. Okay, I'm gonna say just type here. Now, all we do here is say var new block, and we are gonna create an instance of the block preload here, prefab of the scene. Now we're gonna say new block dot translate. So we're gonna set the position of the new block to the position parameter. Now we're gonna say new block the type, and we're block type. I named it block type, right? Yeah, block type. And we are gonna set it to the type, and then simply add it to the chunk new block. Okay, so now we can create the new block here. So we're gonna say new block, and the position is gonna be a vector 2. And let's see, so if we would put just an x and y here, we're still talking in the in the block units, or how to say it. So we need to multiply it by 32, so we would work in the actual like pixel units. Okay, and now we're gonna set the block type, which is gonna be the grass block. Okay, so here we're saying that the surface block is gonna be grass. Now we can test this out. So I'm gonna instantiate the chunk instance in the world, and let's run this. Oh, we didn't choose the default scene, world.sen. Now you can see that there is some terrain generation going on. What I'm now quickly gonna do is create a camera 2D so I could move around the world, and quickly gonna create a script for it. Let's put it in the scripts folder and call it camera. Let's save, create, and let's just quickly say set process true. So the process function is gonna be called every frame. Process, and let's say if input dot is action pressed UI up. So if the up button is pressed, I'm gonna say translate vector 2 0 by, I don't know, I'm gonna create a variable called var cam speed and set it to like 10. So I'm gonna say move by the cam speed. Okay, if I press up, I'm gonna move on the Y up by the cam speed. Now I'm gonna repeat this for every key, for every direction. I'm gonna say down, left, and right. Then I need to set the camera to current and no drag margin. Okay. Now we can see that there's a terrain here. Okay. I'm gonna say that this is gonna be fixed up left. Okay, let's get back to the chunk generation. So what we need to do now is to create the whole like chunk and to fill it with, you know, dirt, stone, and then bedrock. So let's create a new for loop, and it's gonna hold a y variable, and it's gonna be for y in range. Now the range is gonna be from the current y plus 1, because I don't want to create a block on the current y. I want to create a block starting from below the current grass block, and from y plus 1 to world depth. Okay, so now I can create a new block in there, and it's gonna be on x times 32 on the same x, and on the y times 32 now, and I'm gonna say it's gonna be dirt. Okay, now it should create what did I do wrong here? Okay, I didn't put a parenthesis here. Okay, now it should work. Now we get a dirt block up to the lowest point in the world, but we don't want it to be only dirt. So now what we are gonna do is create a new noise, or generate a new y for where the stone for the current x starts. So I'm gonna say var stone y equals to, again, floor soft noise dot open simplex 2d, and the x is the current x. I mean, the x is obviously again the same x, and I'm gonna multiply it by the same number. But I don't, now if I would put y to 0, it would give me the same noise value as the surface y, which we don't want because it will look really dumb. So I'm gonna set the y value to something like 32, so it would give me a completely different y value. Now I'm now gonna multiply the noise by some number, which is gonna determine the height of the variation in the stone height. So I'm gonna say 4, for example, and close it off. Okay, so now we have the stone y, and now we want to create dirt until it reaches the stone y. So if y is bigger, then now bigger than what? I want to make it relative to the world depth. So I'm gonna say world depth times 0.25. Now this says that it's gonna start creating the stone at the quarter of the world depth. So there's that, and then I'm gonna say plus the stone y, which is gonna, you know, take into account the stone y variation. So now, if that's the case, I'm gonna create a new block similar to here, and it's gonna be stone. And if it's not below below this value, I'm gonna create dirt. Okay, let's see what we have here. You can see that we now generate stone. Okay. Now, what we are gonna do next is generate the bedrock layer. What I could simply say here is create the bedrock at let's see, vector 2 x times 32 at the same x, but I'm gonna say the world depth here times 32. And what this would do is bedrock, of course, and what this would do is it would create like a flat bedrock layer in the bottom, but we want it to be a little varied. So to take that into account, I'm gonna create a new y called bedrock y, which is gonna again be of soft noise open simplex, and here again I'm gonna say the get global, you know, so it would be relative to the world size, the chunk position in the world. And again, I'm gonna multiplied by some numbers. Let's do something different now, like 0.5. And now the y parameter is again gonna be different from these two because I want it to be different. And yeah, I'm not gonna multiply it by any variable now here because I don't want it to be that like varied, the height of the bedrock that varied. And this is it. So now instead of going to the world depth, I'm gonna go to the world depth plus bedrock y, which is gonna go to the world depth plus the variation in the bedrock y. And now I need to create the bedrock with that variation. And I'm gonna put it into parentheses because it would multiply by 32 the whole sum. Okay? Now if we look at this, we can see that we get a varied bedrock layer. Now we can play with these variables here. I can, for example, say the the surface height to be 128. So we would get like mountains or something. You can see that now it's much higher. And so yeah, you can like generate chunk like this, like mountains, grasslands and stuff. So this is basically what I wanted to do for this tutorial. What we can do now is create a few more chunks. So I'm gonna create a world script, call it world script, and put it into script folder. Let's get the chunk scene and preload chunk. Okay. And let's also generate a seed in the world script because I want the seed to be same for each chunk, so the noise would be the noise would connect from chunk to chunk. So I'm gonna say world seed. Oh, this is already taken, so I'm gonna say like world seed. Now in the ready, I'm gonna say randomize, which is gonna make sure for us that the random number is randomized. And I'm gonna say world seed equals to rand int, and I'm gonna say times, I don't know, a lot, so the world seed would be really random. And now let's create the chunks. So I'm gonna say var new chunk equals chunk dot instance and add child new chunk. Now I'm gonna make a few more chunks to the left and to the right. I'm gonna say new chunk dot translate, and I'm gonna say vector 2 minus so the minus here I need to, if I want to create a chunk on the left, I need to do minus the chunk width times 32. So chunk width is 32 and 32 squared is 124 if I'm not mistaken, and on the y0. Now let's also create a new chunk to the right of the center chunk. Now if we... Oh, also I forgot to get the seed from the world. I'm still using the hard-coded seed here, so I'm gonna say get node the parent dot world seed. Okay, so now it gets the world seed. So I seem to have found a weird bug, but now it works. What I now did is I deleted the chunk in here so it wouldn't intersect with the script added chunk. Now if we press F5, we can see that we have a few chunks that are smoothly connected to each other and nicely generated. So this is gonna help us when we make the world infinite, but this is what I wanted to talk about today, and yeah, see you next time, I guess.